Well, welcome to 2.3. So let's get started. We're dealing with decimals, right? This time. We know that fractions are numbers, right? So therefore, we should be able to represent them in our base 10 number system. This is from the reading. So recall that this is a place value system, our base 10 system, so that the numbers 75,963, as you know, is comprised of 5 separate numbers in different place values. So the 7 is in the 10 to the 4th place. 10 to the 4th means 10 times 10 times 10 times 10, which is 10,000. Likewise, the 5 is in the thousands, the 9, etc., down to the 3, which is 10 to the 0, which is the ones place. So fractions are going to be less than 1, proper fractions. So we need powers of 10 over here, powers of 10, that give us numbers less than 1. So here is our number system. Notice that, let's start at 1. 10 to the 0, just by definition, is 1. Anything to the 0 power is 1. 5 to the 0 power is 1. 3/4 to the 0 power is 1. So any number except 0 to the 0 power is 1. That's just by definition. So now as we move to the left, each place value is 10 times bigger than the previous one. That's 10 times bigger. 100's 10 times bigger than 1,000. 1,000 is 10 times bigger than 100. And that's what happens when we go that way. Now when we go the other way, we take 1,000, divide it by 10, we get 100. So it's 10 times smaller going this way. Divide 100 by 10, I get 10. Divide 10 by 10, I get 1. Divide 1 by 10, I get 1/10. Divide 1/10 by 10, I get 1,000, 100, and then 1,000. So that's the third decimal to the right. Notice the notation in exponential form. 10 to the negative 1 means take 1 divided by 10. 10 to the negative 2 means take 1 and divide it by 10 squared, which is 100. So that gives us our tenths, hundredths, and thousands, our decimals. So it causes a few problems, right? One, we no longer know what the rightmost symbol is in the ones place. We need something to define the difference between the ones place and the decimal places. So we have a decimal point. We also need to know how to add fractions. We're going to represent fractions as a sum of tenths, hundredths, and thousands. And we need to be able to represent fractions as a sum of tenths, hundredths, and thousands. Some fractions, like 1/3, require an infinite number of these units. For instance, if you even just 1/3, and decimal notation is 0, no ones, 0.3/10, 300ths, 3,000ths, 3/10,000ths, 300,000ths, like that. So in order to represent it, you have to have an infinite number of 3's, 0.333 forever. That's usually denoted with a bar over it. That means repeat forever. So we're going to express the decimal 23.74 as a sum of place values. This is 2.13, so this is just in the reading. And interpret this sum of place values using currency. So I'm going to drop these in. 2 gets dropped into the tens place. 3 gets dropped into the ones place. Then there is the decimal. And then there's 7 of these and 4 of these. And looking at it more closely, there's 2 tens plus 3 ones plus 7 tenths plus 4 100ths. So that was written like that, 7/10, and that would be 4/100. This would be 20 plus 3 plus 7/10 plus 4/100. Now let's look at it as currency. So briefly, we had 23.74, and we can interpret that using money. So, and that would be 2 $10 bills, 3 $1 bills, 7 dimes, and 4 pennies. So this is what we added here. This is our decimal point. So this 2.13a, this is one you're responsible for in terms of taking a photograph or handing in. So this one you want to make sure you take notes on. And we're going to look at these different bases, a base 5, a base 2, and a base 16. And we're going to look at how we represent fractions in those bases. So first of all, with the base 5, we're dealing with powers of 5. So you move this way, that's 5 times bigger than 5. That's 5 times bigger again. And you move this way, that way is 5 times bigger, and this way is 5 times smaller. So you take 25 and divide it by 5, you get 5. You take 5 and you divide it by 5, you get 1. So you take 1 and divide it by 5. And then you take 1 here and divide it by 5 again, or 2 5s. So those are the two decimals, first two decimals to the right in a base 5 system, represented by 5 to the -1, you're correct, and 5 to the -2, etc. So looking at this number, 20.3 base 5, I'm going to drop the 2 here, the O here, there's the decimal point, and there's 3 of those. So I got 2 5s, which is 10. I got 0 1s, and I got 3 fifths. So that number you would know as 10 and 3 fifths. So here's our base 2 system. Going from left to right, divide 4 by 2, you get 2, so it's base 2. Divide 2 by 2, you get 1. Now you divide 1 by 2 for the first decimal to the right of the decimal point in a base 2 system. And then this would be 1 over 2 times 2, which is 1/4. And guessing here, 2 to the -1 and 2 to the -2. That's how you represent it. So we got 11.01. So I'm going to drop these in. 11.01. So I have 1 2. I have 1 1. And I have 1/4. So I have 3 1/4. And finally, for our base 16 system, going from left to right, 16 is 16 times smaller than 256. 256 divided by 16 is 16. 16 divided by 16 is 1. 1 divided by 16 is 1/16. And 1 divided by 16 times 16 is 1 over 256. So this is going to be 16 to the -1, and this is 16 to the -2. And hopefully you see all the patterns here now. A in base 16 is 10. You can have 10 in a single place value because it's base 16. You don't regroup until 16. And then we have 4 here. And then I have 4 here. Decimal point with 4 there, 4 of those. So I got 10/16, which is 160. Plus I've got 4 1s, which is 4. Plus I have 4/16. 4 of these. 4 of the ones. So this is 164 and 4/16. So this just shows you that all the systems are basically the same in terms of the pattern. So here's the thought question associated with that. It says, what are the first two place values to the right of the decimal in a base 8 place value system? Well, I would put it on pause and give that some thought. Let's put the decimal right here. I'm going to put it somewhere. I'll put it right there. That's the decimal point. That separates the ones from the fractional remain. So this obviously has to be 8 to the 0 power, because the first place value is always the ones. And then the next place value will be 8 times bigger. So that's 8 to the first power, which is 8. And then the next place value will be 8 times bigger, which is 8 times 8, which is 64. So if you remember the pattern, this has got to be 8 to the negative 1 and 8 to the negative 2. And so we just want to find these two numbers here, this one here and this one here. So if we're moving from left to right in this system, every number is 8 times smaller than the previous number. So this has to be 8 times smaller, so we take 1 and divide it by 8. So there's the first place value is 1/8. And the second place value, hopefully you can recognize the pattern, is 1/64. So that's just in any place system, you should be able to build that. So we want to write these three fractions as decimals. Hopefully you read 2.14 and got a little idea what we're doing here. This is the one you're responsible for. We're going to write them as decimals. Deci means 10, right? Deca means 10. So this is that's why they call it decimals. So decimals have units or denominators like that, or like that, or like that, and et cetera, right? That's the denominator in our decimals. We can't have any other denominators. So we're going to take 4/8 and make it into a decimal. Well, it's easy, like, let's do this one first, 7/20. Can you see, hopefully, that there's, if I multiply the denominator by 5, I multiply the numerator by 5. And so I'm going to get 35 over 100. And that's what I need. I need one of these, and I got 100, so that's good. So 35 hundredths is going to be 0.35. 9 over 300, I can divide the numerator by 3, and I can divide the denominator by 3. And that'll get me to 100 here. I got to get to 100, 1,000, or 10. And that's 3 here. Now be careful here. It's not 0.3, because there's nothing in the tenths place, but there's 3 in the hundredths place. 4/8, if you can see that that is 1/2, that's going to make your life easier. Or if you can reduce it, right? 4/8 is the same as 2 times 2 over 2 times 4. These will cancel and you get 2/4, or you can then 2/4 is 2 times 1 over 2 times 2. And you get 1/2. So from 1/2, I can multiply this by 5 over 5 and get 5/10. Being that I have a denominator that is one of my decimal denominators, right? Here's my decimal denominators. I can simply write this as 0, 1s, and 5.5, which is 5/10. So these are equivalent forms of writing in the decimal system. fractions. Now 2/3 is a little different. I can't get to 10. I can't multiply it by anything to get to 10 that I can see easily. So the other way of doing this is dividing. And a lot of times students will make this mistake. They'll go 3 divided by 2. I get 1 there. 1 times 2 is 2. But that is not right because this number here is less than 1. So I'm not going to get anything in the ones place. So it's 2 divided by 3. I get nothing in the ones place. And now I'm going to the tens place. And the only thing I'm doing by adding a 0 is changing 2 to 20 tenths, which is the same number. And so how many 3's can I get into 20 tenths? And the answer is 6. 6 times 3 is 18. I get 2 tenths left over. You put a 0 there because you're changing 2 tenths into 20 hundredths. 2 tenths is 20 hundredths. And so I get another 6. 6 times 3 is 18. I get another 2. And you can see that this is going to go on forever. So 2/3 as a decimal is 0 ones, 6 tenths, 6 hundredths, 6 thousandths, 6 ten thousandths, etc. So we put that bar over it. Okay, so we're going to write these numbers as a sum of whole numbers and fractions. All right? So let's start with right here. That first place value, that 1, is actually a 10. So I got a 10. And then I have 2. And then I have 0 tenths. And I have 6 hundredths. So this is 12 and 6 hundredths. Nobody's asking you to reduce. So this one here I have the 4 is a 400. And there's 2 tens, which is a 20. I have 1 tenth. And I have 4 hundredths. So this is 420. And how do I write this? How do I combine these? Well, let's take 1 tenth and turn it into hundredths. Then I can add them, right? So times 10 over 10. I get 10 hundredths. So this is 10 hundredths plus 4 hundredths is 14 hundredths. You don't have to go through this if you kind of like got that. Like this one, I'm not going to go through that well, maybe I will. We'll see. So I got 50 plus 2 hundredths plus 6 thousandths. So I have 50 and 26 thousandths. And I'll show you how I got that. I took the 2 hundredths here. And I know that 2 hundredths is the same as 20 thousandths. Because if you multiply the top by 10 and the bottom by 10, that's what you get. So these two are equivalent fractions. So 20 thousandths plus 6 thousandths is the same as 20 dogs plus 6 dogs is 26 dogs. In this case, our unit is thousands. So this one I'm just kind of going to do. Watch this. So this is, I know that I need a number in every place value until it ends, right? So let's just start here. There's a 4 there. Now I need, that's in the third place value. I don't see anything in the second place value, so I'm going to put a 0. I have a 5 in the ones place value. I have a 2 in the ones place value, the tens place value, the ones place value. See how I did that? 4052. Then I have a decimal point. Then I have a 3 in the first position to the right of the decimal, which is the tenth place. I have nothing in the second place because there's no 10 to the negative 2. And finally, I have a 4 in the third place. So if we want to write it as a fraction, it would be 4052 and 304 over 1,000. And how did I get that? Well, we know that that's 4 over 1,000. That one. This is 3/10. This one. I want to change it, the bottom number to 1,000 so that I can add them, right? 3 times 100 is 300. 300 thousandths plus 4 thousandths is 304 over 1,000. So here's what you have to submit. And that should be a word, not, I don't change that. So this is what we're going to take pictures of, these pages for this section, and submit them to Canvas. Now this is what we went over in the video. So those you can just copy from the video. Here starts the homework. Complete the following table. Expanded form with fractions. So you're getting a standard form of a decimal and you're writing it in expanded form. And I gave you an example right here, so that shouldn't be very hard. This one you just have to go backwards, but that's not very hard either, right? So we don't need to do one of those. Let's do let me give you an example of one of these. So let's pause here. So we're going to add these mixed numbers. So I'll do the first one here. I think what you really need to do is recognize how these are constructed. And you don't have to go through this whole process I'm going through, but I'll do it one time here. So this is 2 plus 5/10 plus 3 plus 7/10. So I can just add the whole numbers because the order in which you add doesn't make any difference. So I get 5, and if I have 5 of these and 7 of these, I get 12 of these. Now 12/10 is more than 1, right? So I can regroup. 12/10 is really 1, 10/10, and 2/10 left over. So I can make this 6 and 2/10. And you want to regroup. You don't want to leave an improper fraction as a remainder. So let me do one more. Let's do this one. And now I'll do, let me see. How about just, okay, I'm going to leave this one for you because you need to be able to handle that. How about this one? I'll start it off anyhow. There's no ones. These are 3 different place values. There's 6/10, and then there's hundreds and thousands. So it'll let you handle that. So there's a little help on 2. On 3, you're writing fractions as decimals. So again, the only thing you want to do, and these are simple ones, like you're going to see on the test, because we're not doing dividing to find the decimal notation. We're just simply changing the numerator, the denominator, so it's one of our base 10 fractions. So in other words, like 2/5, if I multiplied it by 2 over 2, I would get 4/10. 4/10 is 0.4, right? And this is the last problem. And I will do this one here, just to refresh. So we're given the exponential form of a fraction, right? And we want to write it in fraction form and then in decimal form. So I'm going to do this 11 times 16 to the negative 1. Well, 16 to the negative 1 is the first place value in a base 16 system to the right of the decimal. So it is, and I have 11 of them. So it's 11/16. Now, it's going to be really difficult on this one to get this to have a denominator of 10 or 100 or 1,000, etc. So the only way to really do this one is just to simply divide. And so I'm going to go 11 divided by 16. And being that that's very annoying, I'm going to do it on my calculator. And I get 0.6875. I'm certainly not going to give you one like that on a test where you don't have a calculator, right? Just so you can see. So 11/16 is the same as 6/10, 800ths plus 7,000ths plus 5/10,000ths. So that's kind of what you're doing here. You're just converting forms.